This is the 2020 paper 1 and this is question 8. So what we have here is we have a functions and calculus question. So swimmer is on a starting block at the beginning of a race. When she dives off the block until she resurfaces, the level of the swimmer relative to the level of the water is given by this function. So in the function, x is the horizontal distance in meters of the swimmer from the block, where x is greater than or equal to 0 but less than or equal to 12, where it's an element of the real numbers, and h of x is measured in meters. So find the height of the block above the water. So if it's above the water, then it means that h is 0. So we're going to try and find the h of 0. So that's 1/60th by 0 squared minus 1/4 by 0 plus 3/5. So that means that it's, when you put that into your calculator, it's 3/5 meters, or 0.6. So that's 5 marks. Show that the swimmer is on the surface of the water, where hx this time is equal to 0 when she is 12 meters from the starting block. So this time x is the horizontal distance of the swimmer, so h is 12, so we're going to put in h12 into our function. So that's 1/60th by 12 squared minus, minus 1/4 of 12 plus 3/5, and we want to see what does that give us. So we want to see if it gives us 0, so we put it into our calculator, we get 0, so 0 is equal to 0 here. So show that the swimmer is on the surface of the water. So because the height here is 0, then she's on the surface of the water, so 0 is equal to 0, so that's correct. Then you want to find the horizontal distance in meters from the starting block to the point where the swimmer enters the water. So we want to make the function of 1/60th x squared minus 1/4 x plus 3/5. We're trying to find what x is the distance, so we make it equal to 0. So we can see the easiest thing to do here is to find the lowest common denominator here of 60. So that means that 60 goes into 60 once, that just remains as x squared. 60, so 4 goes into 60 15 times, so 15 times 1 is minus 15x. And 5 goes into 60 12 times, so 12 times 3 there is 36. So now we have a quadratic function that we can deal with a lot easier. So if we look at the factors of 36, so 1 times 36, 2 times 18, 3 times 12, 6 times 6, and 4 times 9. You're trying to see which ones give you minus 15. And that would be minus 3 and minus 12. So that means that x is equal to 3 or x is equal to 12. So we want to get, so the answer is greater than or equal to 12 at the start. So you don't want to pick the 12 because that's the starting point, so you want to go with the 3. So x is 3. So that's 10 marks. Then for part C, so here find the h dash of x, so the first derivative of your function. So 2 times 1/60 is 2/60, which is 1/30th x. So that's now x. And then we've minus 1/4. Drop the x, and 3/5 cannot be differentiated. So that's your h dash of x. So that's 10 marks. Then from part 2, use your answer from part 1 to find the horizontal distance in meters from the starting block to the point at which the swimmer reaches the greatest depth. So you're looking for the local max here. So we're trying to make our first derivative equal to 0. To try and find the value of x. So that means that 1/30th x is equal to 1/4, just bring that across. and then you want to divide 1/4 by 1/30. So that means that it's multiply 1/4 by 30/4. So 30/4 is the same as 15/2, which is 7.5, and that's in meters. So that's 5 marks. And then they want you to find the greatest depth. So once you know that x is 7.5 meters, that's when it gives you the greatest depth. You just sub in h of 7.5 into the original equation. So that's 1/60 by 7.5 squared minus 1/4 by 7.5 plus 3/5. And when you put that into your calculator, get 0.3375 meters, and that is 5 marks. For part D here, so in 2016, Submarine Olympics, Michael Phelps won the 200 meter butterfly final in a time of 1 minute and 53.36 seconds. The time it took to swim each of the 4 50-meter sections of the race and split time is given in the table below. The percentage increase in the time taken to swim one section is also given. Thus it took the swimmer 14.7% longer to swim the second 50 meters compared to the first 50 meters. So what we're trying to work out here are the missing gaps. So for the first one, we need to find the difference between 29.33 and the previous time there of 28.5, and then you always put that over the original time. The original time was 28.5, and then you just want to multiply by 100, and that gives us 2.91%. So here they want the answer to 1 decimal place, so I'm just going to say 2.9%. And then for the next one, you find the difference between 30.68 and the previous one, which is 29.33. And then again, you put that over the original of 29.33 and multiply it by 100, and you get 4.6%. Okay, so that's 10 marks for that one. Okay, so to find what x is here, we're going to have to do x minus 25.01 over 25.01 multiplied by 100 gives you 4.7%. So the easiest thing to do is just to do the opposite. So x minus 25.01 over 25.01. And instead of multiplying by 100 here, if you just divide it by 100, and then you get your small decimal there of keep that over 25.01, so you get 0.047, and then what you can do now is cross multiply, so then x is equal to 25.01 times 0.047, and then if you add the 25.01, you'll end up with 28.686. Okay, and if you do the same thing then for the rest of them, so y minus your new answer here. So I'm just going to fill in what x is. So x is 28.69, 62 decimal places. So for y then, I have to do y minus 28.686. I'm just going to keep it as accurate as I can. Over 28.686 times 100 is equal to 2.9. So I'm making it equal to 2.9% because that's the same time as Michael Phelps. So if you go back to his table, you'll see 14.7 and then 2.9. So that's why I'm making it equal to that. So then you do 2.9 divided by 100, and then you want to multiply by 28.686, and then add on your 28.686, and you end up with 29.518. So that's 29.52, and that was 2.9% because that's the same as the last one, as Michael Phelps. And then I'm just trying to find the last one here, which is Z. So that has a percentage of 4.6%. So for Z, I do Z minus the 29.518 over 29.518 times it by 100, make it equal to 4.6. And same thing again, do 4.6 divided by 100, multiply it by 29.518, and then add 29.518, and you end up with 30.876, which is 30.88. And then to get the total, then just add all the times together, and you get 1 minute 54.09. And you can just press the degree button on your calculator and add it up. When you add up those times as decimals and press the degree button on your calculator, it'll change it into minutes and seconds for you.